Hi, my name is Marco, and I would like to welcome you to the Disruptive Innovation Festival. We're halfway through the third and last week of this online festival that asks the question, what if we could redesign everything? I'm very pleased to introduce you today to Dwayne Nelson, CEO and President of EnviroLeach Technology, a company that proposes an environmentally friendly alternative to extracting precious and strategic metals from electronic waste using water and non-toxic FDA-approved substances. With us is also Leslie Michael, who will be chairing this session. He's a writer in the topic of financial honesty and also author of Money Uncensored. Just to let everyone know how this session will run, our speakers will make an introduction to the topic that will be followed up in about 15 to 20 minutes by a discussion. So don't forget, this session is interactive. We love to hear your comments and questions, and you can post them in the chat box below, and we'll try to pick them up and discuss them during this session. Dwayne, please take it away.
Hi guys, can you hear us? Well, I'm Leslie. I'm the Director of Corporate Communications for EnviroLeach Technologies. Beside me over here is Dwayne Nelson. He's the CEO of EnviroLeach. And just a summary before we start, we have something that's very special, something that we think is going to disrupt the entire e-waste space. And we're here to talk to you guys about it. And without further ado, I'll just introduce you to Dwayne.
Hi, thank you very much. To get right into it, EnviroLeach Technologies is a company that was formed about 3 years ago. I have a mining background and had numerous mines throughout Mexico, which we sold, and wanted to focus on environmental alternatives to mining. And we came across an idea for a formula, and typically in mining, almost all of the extraction techniques are not very friendly to the environment. In most cases, most gold is extracted with the use of cyanide, which is a poisonous chemical. Although it's been used safely, it does have a deleterious environmental footprint on the environment. There's no doubt. The industry's been looking for an alternative to cyanide for 100 years. We finally came up with something that rivals the performance of cyanide. In other words, the leach kinetics of our product extracts or dissolved gold as fast as cyanide or some of the other acid alternatives, such as aqua regia. There's very few chemicals in nature that will actually dissolve gold. So we were very pleased when we started seeing our results. So it's been 3 years and over 15,000 individual tests with independent valuations along the way. And what our formula consists of is there's 5 salts, 5 ingredients that we mix with ordinary tap water. And each of the ingredients are actually FDA approved for human consumption. The product is then introduced into an electrochemical process where De Beers is actually growing pure diamond substrates for us, and we pass electrical charges through these individual substrates, and that electrochemically alters the formula. So now it will dissolve gold, platinum, palladium, copper, nickel, rare earth minerals, rare earth elements, and so on into solution. But what's interesting is you can drink the solution. You can put your hands in it while it is dissolving the gold. There's no off-gassing. It operates at a neutral pH. It really is a phenomenal discovery. And we're working with a lot of the major gold mines, gold mining companies around the world. And now, as of late, from the last 14 months, we've been focused with a company called Jabil, who's the 3rd largest manufacturer of e-waste in the world, or electronics in the world, on an e-waste project. Together, we are trying to come up with an economic, cost-effective, safe, and environmentally friendly solution to deal with the 50 million tons of e-waste that are currently being generated worldwide. That number is expected to go to 78 million tons by 2026. And the amount of gold, precious metals, copper, and nickel that is contained in this e-waste is monumental. And very little of this is actually being recycled. So if you look at Apple, Cisco, HP, Dell, Microsoft, Google, all of these companies are looking for an environmentally friendly way to recycle it, to move into the circular economy. And, you know, the benefits of that are obvious. There's less carbon footprint from mining. There is less waste. There's less material going into the landfills. The amount, as I said, the amount of this material is unbelievable. So what we're doing is we just simply take the e-waste and we submerge it in our solution. It strips the gold, dissolves the gold and other metals into solution. We then filter the material, that what we would call the tails, and then we would extract the gold and precious metals from solution using either electrowinning, precipitation, carbon absorption, and so on. And even more important, those tailings that we produce, we actually sell to smelters around the world because of the high carbon content, or the high copper content, especially at 10 to 15% copper per ton. The fluid is actually recycled and reused. So not only are we providing an environmentally friendly and safe and sustainable solution to the electronics in the e-waste sector, but our formula itself is sustainable. So after we pull the gold out, we simply put the fluid back through the diamond substrate material and recycle it and recharge it, and it goes right back into the tank for reuse again and again. So there is we actually can operate with a zero environmental footprint. There's no effluent, there's no water effluent, there's no off-gassing, and of course all of our solids or tailings that are left over are actually sold back to smelters, which repurpose that again.
I have a question. With regards to, there are other alternatives out there, so there's like thiosulfate, thiourea, and different halides. Why hasn't this happened before in this last 100 years?
Well, I mean, that's the big question, but it's quite simply, anybody who's involved in any type of a disruptive technology knows that just because something hasn't happened in the past doesn't mean it can't be innovated and recreated or created in the future. There are a couple of other chemicals that you had mentioned that have been tried in this, but inherently they're all unstable and uneconomic for one reason or another. The key was finding solutions that could dissolve the metals, but even more importantly, be able to hold them in solution in an effective economic way so that they can be extracted later. It's not good enough to dissolve it and have it fall back in the solution.
So also the scalability factor, so the other ones aren't scalable as well, and they have to be cost effective at the same time, and they have to hold gold in the solution.
Yeah, you know, the acids, just the hot acid baths that people have tried in the e-waste sector, it just doesn't work. It's not scalable. The amount of SOx and NOx and the off-gassing is tremendous. The poisonous nature of the material, but even more importantly, it self-destructs. The process is very, very limited because the materials that you're using are inherently subject to the same acid that's going to be.
So the Ellen MacArthur Foundation did a really good video on the circular economy with regards to, you know, you take your iPhone, you buy your iPhone or whatever cell phone device or laptop or whatever, you use it, and then they want it, you know, it gets destroyed. They want demand destruction, and then they want all the parts inside of it recycled and be reused so that there's 100% sustainability. So I believe Lisa Jackson, I believe, is the person who was the one spearheading this several years ago and has now made progress from Apple, who is one of the Jabil's clients. And so everyone is kind of moving in this direction. Maybe you might want to explain where we are in that progress.
The benefit of having somebody like Jabil as a partner who actually build the iPhones and the HP, Cisco, Dell, is that they have the relationships and their ability to leverage these relationships, not just on the manufacturing front, but to offer our green label on a box to say that the end of life of this electronics is handled with care. And the ability for us to recycle not just the gold or the palladium or the some of the rare earth metals that are contained, but even the aluminum boxes, the plastic, the leads, the tins, and so on. We feel that we can be part of the circular economy to mitigate the amount of precious metals and other metals that actually have to be mined in order to reduce the environmental impact of the electronic sector. No one else has been able to come up with a formula that can economically address these.
One of the things that everyone's kind of asking about is the carbon footprint. Like, maybe we can explain, like, from the mining point of view, how much like CO2 is actually mined, like per ounce, sort of, as an example, for how much, the differences between carbon footprints between others and what EnviroLeach does.
The companies are now just starting to report what their actual carbon footprints are. And there's been a number of studies that we've looked at that most of the studies indicate that it takes about 1 ton of CO2 equivalents to produce 1 ounce of gold. And that's everything from the extraction of the gold, the processing of the gold, the production of concentrate, the treatment of concentrate, the shipping. Obviously, this all has a dramatic effect, but 1 ton of CO2 per ounce of gold is excessive. The reports that we're seeing now indicate that by recycling that same ounce of gold, we can reduce those carbon footprints by up to 90%.
So let's maybe we should talk about our first plant that's going to be up and running next month in Tennessee, and what our where is this going? This part of the whole extracting electronic waste.
Well, as we said, there's 50 million tons being produced today, most of it going into landfills. So our plant in Memphis is actually a Jabil facility. It's a 650,000 square foot facility, and we're installing a 10-ton per day plant. So we'll be initially processing 10 tons of computer cards every day, extracting the copper, gold, nickel, and other metals out of that. And then almost immediately, we see an opportunity to build 3 more plants, each capable of doing 50 tons a day. And when you look at that, each plant, it's 16,000 tons. And in North America alone, there's some 20 million tons of this e-waste that's being discarded every year. So, even at that amount, with us being the largest recycler or provider of this type of service outside of the typical smelters, it's really just we're just scratching the surface of this sector, and we've had over 20 inquiries worldwide for this type of technology
from different countries, right?
Exactly. Yeah. So with Jabil, again, we're a small company. I think between Jabil and our own staff on this project, we're less than 100 people, but Jabil has 175,000 employees in over 100 locations worldwide, and they have made it clear that they want to make this entire application. They want to own this sector, and there is the potential for Jabil, an electronics manufacturer, to actually become one of the largest gold producers in the world and never have an operating mine. And we're all very excited.
This is big. Maybe one of the things, the differences between a mine, we've had well over 100, probably close to 200 mining companies also come and talk to us. But the lowest hanging fruit for us is definitely the e-waste sector because of the amount of gold. A typical, maybe we can talk about a typical amount of gold that you would find per ton versus a mining and versus electronic waste.
Okay, and we'll get into the PowerPoint that actually provides a little more insight into this. But again, being from the mining sector, if you look at the average grade, how many grams of gold per ton in the mining sector today, it's about 1.2 to 1.8 grams per ton. The average e-waste that we're addressing now is somewhere in the neighborhood of 100 to 200 grams per ton. And again, when we're talking about leaching, EnviroLeach indicates that what we're doing is leaching or dissolving the gold. Typically, 1 ton of ore or concentrate requires 24 hours to soak, either in cyanide, acid, or in our solution. But what's interesting is with the e-waste is that we're able to extract or dissolve that gold in a 1-hour cycle. So effectively now you've got 100 grams per ton to start with, but your ability to process is 10 times greater than it is on the conventional ores or concentrates.
On that note, I'm going to call up the PowerPoint presentation. Hope you guys can all see this. So, by the way, you can follow us on Facebook, Twitter, and LinkedIn. And a little bit about where we are. So, we're a technology and urban mining company producing gold from e-waste using environmentally friendly formulas. Everything we do is patent pending. All the ingredients are FDA approved. You can basically drink it after it's used. We don't recommend you do that. Our objective is to be a leading gold producer through urban mining. That's what we call recycling electronic waste, end-of-life electronics. These are the current extraction processes that are used in mining and e-waste. Smelting pretty well dominates the electronic waste side, and then cyanide pretty well dominates the mining side, and the acids are used mostly for extracting electronic waste, and none of them are scalable, and a lot of it is toxic, so that's where we come in.
Yeah, I was just going to mention, that the use of cyanide in smelting are obviously scalable. They're handling hundreds of thousands of tons of material, but smelting in itself, there's very limited capacity. The amount of CO2 emissions are extensive, high carbon footprint, plus you've also got to ship the material to the smelters. Cyanide is scalable, but obviously it is not an effective alternative. Our formula can replicate any of these, but has a zero environmental footprint. Oh, as we mentioned before, for every 1 ounce of gold that's mined, some calculations, it seems to be the average is assumed that it's about 1 ton of CO2 equivalents are produced for every 1 ounce of gold that's produced. And again, by recycling the e-waste, we feel, and other reports indicate that we can reduce that by up to 90%. This gives you, if you look at the process comparisons of EnviroLeach versus the acid digestion, cyanide, and smelting, this radar chart actually indicates, you can see we're in the dead center there. Obviously, with much lower environmental impact, it's a simple solution, low operating costs, low capital costs, and very, very low safety concerns. So this indicates or kind of demonstrates.
Sorry, Dwayne. I think can you switch to the radar diagram? It's not visible right now.
Oh, can you see it now?
It's not.
Okay, that's fine.
Right now. But yeah, if you could just explain it, because it's not visible. Yeah.
Okay. What it shows is a footprint based on the 5 different. I'll just wait for him to bring it back up again. It demonstrates in the radar chart that if you look at all of the other processes, what is the impact, or what is the comparative process complexity, operating costs, capital costs, safety concerns, and of course environmental impact. And EnviroLeach is in the center with the very smallest impact of all of those different processes. I'm sorry.
And may I just interrupt to ask, and I think you were discussing this right now, but there's other recycling technologies such as pyrometallurgy. How does it compare to the technology that you are applying?
Okay, it's a great question. We're very lucky. We've had partners from Australia, New Zealand, Germany, from the U.S., in Canada. And all of them have tried a number. Everybody has tried a number of alternatives for the extraction of the gold. Mechanical separation does not work. You cannot remove gold from the substrate itself in a mechanical nature without losing most of the gold that would be surrendered to the substrates. So mechanical gravimetric, one of our partners is Sepro Mineral Systems, who's one of the lead gravity separation or gravimetric separation specialists in the world. So they have tried this. We've worked with groups in New Zealand, from Germany, and Sepro as well on the pyrometallurgical extraction. Even the treatment of bottom ash from a lot of these large arc furnaces. If you look at another company in the States called Blue Oak, again, it's simply another alternative to smelting. They're putting it into a large arc furnace and they're melting it. Gold by nature is very, very difficult. The smelters lose gold in the fluid. The pyrometallurgical separation of the gold provides you with a 30% mass yield reduction. But now you've got 30% less mass. How do you get the gold out of that fibrous leftover burnt material? Gravity separation will not do it. All of these solutions require a chemical process. Inherently, if you look at the way that the gold is applied to e-waste, it's plated on, it's electroplated on, it's molecular or atomic attachments. So really what we're doing is we're going in and we are attacking the bonds, the ion bonds. So we're actually dissolving the gold into a solution, converting it from AU0 to an AU3, which means we've turned it into a gold complex. And then we would again treat it again after we've separated it and change that ion gold complex back to AU0, which would be a pure gold metal again. So there are other alternatives out there. Everybody's tried them, and none of them are effective.
Thank you. That's a very good answer. And another question, a lot of the discussion right now has focused on gold. Is it that because this technology is particularly good for gold, or is it equally good for all the other metals in consumer electronics?
Obviously, gold is where the majority of the value is in e-waste. So, that being said, there is a lot of copper, nickel, tin, lead, zinc, rare earth elements, but predominantly gold is what's driving the sector right now. And for us as a company, we consider the gold to be the low-hanging fruit. And just if you look at e-waste itself, gold may represent 6% or less of a PCB card or module, but again represents a significant amount, 75% probably of the value of that small piece of PCB card. So gold is the economic driver of this sector.
Yeah, we've and that it's, and the fact that it can be recovered, it's also positive in the sense that it can drive the logistics and the recovery of electronic waste and prevent it from being landfilled or treated in other less environmentally friendly ways.
Yeah. What's really interesting is that our process itself, by nature, is also sustainable with a zero environmental footprint. We're the only alternative out there that has no deleterious impact on the environment. After our treatment, everything is reused or reused again, or is sent to smelters for further refining.
And a point about the circular economy, I'm working on this topic, so it's clearly of interest to me. But what we prioritize in the circular economy is the reuse and recovery of components. And although recycling is of interest, since we keep the value of the materials, and I was very interested, or I was kind of shocked by this number of the amount of carbon dioxide that is emitted to produce 1 ounce of gold, 1 ton. But still our priority is in the inner loops, since the value of the components and products is kept. Do you think, do you see this as there being a tension between the inner loops and the outer loops as we consider recycling, or you think it's all complementary?
Oh, I think it's extremely complementary. There's a number of studies out, and of course the commitment by the OEMs or the manufacturers of electronics is growing by leaps and bounds with respect to what they want to do for the environment. Everybody is looking for quality end-of-life treatment of their products, and the sustainable or circular economy is you can see that you're limiting the resource extraction, you're limiting the necessary production of that material on the mine or mill side. Then you're limiting the distribution. It doesn't have to be concentrate, no longer has to be shipped from the mine to a different smelter. And then, of course, the amount of waste that's generated by mining, whether it's a liquid waste through tailings or tailings fluid. If we can help to reduce that, but on the same token, reduce the amount of e-waste that's currently reported in landfills, those two combined make a dramatic difference in the whole evolution of the economy.
And another question, I understand that your technology would be used to recover materials from the PCB, from the printed circuit board, that is only a part of the devices.
Mm-hmm.
So how important is for you the design for circularity or design for disassembly of products and recycling that would enable products to easily be separated and the PCB to easily be isolated and put into your processes? Is this important to you, or it's secondary?
It's actually secondary to us, because there's a lot of off-the-shelf projects or processes right now where you can throw an entire computer or a laptop in, and either through eddy current separation, magnetic separation, optical sorting, there's numbers of ways where that material is already currently being separated in an economic way. The whole key was that there's no money in the plastic, there's no money in the steel, the aluminum is messy. Really, again, the driver is the precious metals contained in those boards. So right now we are buying the boards, but it is in or offering our services to the current recyclers that are extracting those boards. But eventually we will be looking at this as a full turnkey process where we can take a single computer and throw it into the front end of the process, and on the back end of the process you have select materials all going out to independent sources for recycling again. But the driver is no one has been able to cost effectively extract the gold, which again is the primary driver, from those boxes. So the cards, it's important that the cards are sorted by the current recycling process, but eventually we look at this as a full turnkey solution.
And now a question focusing a bit more on the long term. How do you see things in 5 years' time? And how do you think this technology can be upscaled? What's your future outlook?
Well, with the amount of e-waste growing, let's call it 2026, they're projecting now 78 million tons of e-waste being produced every year. Obviously, even if we had a plant in every one of Jabil's, for example, 100 locations around the world, each doing 15,000 tons a year, we're still barely scratching the surface. So we are lucky because our technology is easily scalable. It's simply agitated vat leaching. They're large tanks that we put the material in and we stir it, and we extract the materials out, go through simple solid liquid separation. So we hope we can be a big part of this, but even a large company like Jabil combined with this technology will probably still only scratch the surface of what's being produced and what can be effectively recycled or going back into the circular economy over the next 5 years.
Maybe something to add too is that this is the beginning, which means that there's going to be a lot of voices and a lot of thoughts out there that are going to come at us and come at Jabil and come at all the OEMs that are going to add their input, and we will listen to that and be scalable in that regard too. I mean, this is an open topic moving forward.
Well, we're running out of time now, but this was a fascinating discussion. I was very interested, and these numbers of emissions that could be saved are really shocking. And I think, well, it's good to keep it in mind and show the importance of recycling, even if for us who work in the circular economy, we often don't give it such a high priority. Well, so thank you very much, Duane and Leslie. To our viewers, you can learn more about EnviroLeach by visiting their website and also by posting questions in the chat box below, which Duane and Leslie can see and access during the next few weeks. So please ask any questions that you might have. I would like just to flag a couple of other well worth watching sessions that are coming up soon. If you're wondering just what is the circular economy, there will be a session tomorrow at 3 p.m. about exactly that, so don't miss it. And on the topic of design for circularity, also tomorrow at 4 p.m., we'll have glue it like screw modular product design ready to disrupt manufacturing of everyday products, where Mark Miodonik, Eric Loctens, and Lucas Hooks will be discussing how to outsmart material complexity through new developments in material science. That's all for now. Thank you again, Duane and Leslie, and for the viewers for tuning in, and goodbye.